All right, hopefully I give you enough prep to get this thing started. One of the things you had to do, if you didn't do it already, so we got the sample statistic. There's a 10% difference between these two in terms of pregnancy rates. There's a Z value we need to find. Now, you don't look at a Z table. I mean, you could look at a Z table for this and go to a P value of 90% or 5% or 10%, whichever way you want to look at the tails on there. I would look back in your old notes. There's a simple little table that tells you that the Z statistic for a 90% confidence interval is 1.645. We had this in our notes from chapter 5. Real simple, small table that we made ourselves. Now, standard error, that's where bingo, the new formula comes in. So, most of what we're doing today is getting the practice of using that new formula. Nice and convenient if you're around to two decimal places as you're doing that. So the sample size for the smoker group is 135. 28% of them got pregnant, 72% didn't get pregnant. If I was in class, I'd call on people and say, well, you get 38% of the smokers got pregnant. What percent didn't get pregnant? 62%. And then I'd ask, what's the sample size, the other sample size? Well, the other group sample size is those 543 people. Do your calculations, take your square root. You get a very small standard error, really small numbers. It's like 4%. And again, these are percentage points, so it's all relative. We want it to be small. We want it to be a narrow confidence interval. We're okay with that. These sample sizes are pretty large, which is what makes that number so small. You're dividing by a pretty big number in both cases. So we're ready for this thing. We can take this confidence interval now to get the margin of error for 90% confidence interval. We just multiply Z times the standard error times the number we just got. And then we'll add or subtract that to the 10% to see how big that confidence interval is. Now, I think if you multiply, these ends up being around 7%. That's what I have over here for my margin of error. So we're simple. We're adding that 7% on or subtracting it. And you want to see, does this confidence interval stay totally negative? Does it go negative and positive? In other words, does it straddle zero? Is it suggesting that it could work either way? Maybe there is no difference between smokers and non-smokers in their pregnancy rates. And of course, this number is smaller than my sample, so it's not going to allow me to cross over to zero and change the sign of the confidence interval. I think if you add and subtract, you get somewhere between 3 and 17% for a 90% confidence interval. So if I was writing this whole thing out the way we love to do, I'd say I'm 90% confident that women who smoke are 3 to 17% less likely, or non-smoking women are 3 to 17% more likely to get pregnant. So now the moral of the story is not to use smoking as birth control. Okay? Hear me loud and clear. This is a different message we're sending here. Smoking is bad for you. That last little question, hopefully this is on your paper. Hopefully I was smart enough to put that on there. Does the confidence interval suggest that smoking could go either way? Not based on the signs. These are both going to be negatives, suggesting that even if it's a small negative percentage on here, it's still saying that, you're less likely to get pregnant if you smoke. So we'd say no way. That confidence interval does not straddle zero, doesn't cross over zero. Hopefully these made sense. This is the homework to try out in the textbook. Certainly you're welcome to read a little of the textbook as well. It's very good support with all these wonderful words I'm talking to you about. Hopefully it makes sense. Do a little more of this later in the week. Start writing some confidence intervals, questions like this one. Get you comfortable using this formula in this context with confidence intervals. Good luck.